I'm going to shoot a little video about making the stator for this little tiny windmill. Um, Again, it's I made the magnet rotor. This was the original layout. This is the idea behind the magnet rotor. It's 4 inches in diameter. There will be 2 of them. That'll show up in a different video, I suppose, maybe. And the magnets going around it will have 8 magnets, 1 inch diameter, around a steel disc that's 1/8 of an inch thick. And in the end, it'll look a lot like this. I used little popsicle sticks or coffee stirring sticks to space the magnets. That worked out well. Although it would be nice to make or maybe print or cut out a template that possibly even contains these magnets. But this works for a one-off. The stator involves 6 coils for a 3-phase setup. So I laid out exactly the size that the coils need to be. And I wound coils those size, or actually my daughter did. These coils are, a little under 3/8 inch thick, and we wound them just so they fit that space and they're that diameter. The hole in the coil ought to be centered right over the magnet. So in the center of this, I show the size of a magnet, and it shows the space that coil can live in. And when we're winding the coils, I used outside calipers to determine the size. So I could measure off the template and know that the coil must not be bigger than that. That's the constraint. I used 21 gauge wire. Turned out I could fit 120 turns. If I need more turns, I'm still stuck with that amount of space, so I just have to use thinner wire and settle for higher resistance in the coil. But in this case, we're using 120 turns. Coils fit good. So the next step is actually making the stator. Some attention needs to be taken when winding the coils that they're all wound the same direction. So I call this the inside of the coil, and over here's the outside. And before I make the stator, I make sure that they're all wound the same way, and so that the outside, in this case, the outside is going counterclockwise as I look at the top of the coil. I'm defining the top of the coil to be where the inside crosses over. So the inside is coming around over the top and exiting to the left. Outside is going around counterclockwise and exiting to the right. So after I wind the coils, we usually put a twist in there. I'll untwist it and set them all up this way. I set them up this way in advance so I don't get confused. If you get a coil in upside down or wind it backwards, the voltage will cancel and your alternator won't work. You can double check coil polarity by just hooking it to a battery and using a compass to see that you'll see the polarity of the magnetic field that way. I've diagnosed stators that didn't work, that were actually made at factories for commercial wind turbines with the compass, and even the pros get it wrong on occasion. Anyhow, we've got a bunch of coils, or 6 rather, that perfectly fit this space. So the stator, I actually decided to make the whole stator out of acrylic sheet that's it's 100 thousandths of an inch thick, so a little less than 1/8 of an inch. And for a machine this size, this is rigid enough. There's not a great deal of force on the stator, and for a toy windmill like this, I'm not too worried about heat. What I was worried about is how to fasten the coils to a sheet. so we don't have to do any casting. It turns out that cyanoacrylate glue does a pretty good job. I just test glued one coil down here with cyanoacrylate, better known as super glue. I used a medium viscosity super glue on this, and I didn't glue this down real hard either. I could break it off, but it's stuck on there good. If I broke it off, it would make a mess. I can hear the glue cracking a little bit. I don't know what's going to break first. It's stuck. It's stuck good. So in order to build the stator with some degree of accuracy, I'm going to get a blank sheet here. Actually, I want to put a piece of steel down for this. I'll be right back. The magnet rotor is 4 inches in diameter, so I know the outer edges of the magnets will be 4 inches. So I'll draw a 4-inch circle. So the outer edges of the hole in the coil should come right to that circle in the finished stator. I know there's 6 coils, so I'm going to divide this into 6. If we divide a circle by the radius of the circle, it'll divide into 6. Some people would just use CAD or something, but I don't know how to do that. Stuck with a compass. And usually when I'm doing this, I'll go around halfway, and that's enough, but if I could find my original hole. There it is. And then double check it. I'll just come around here and make sure that math still works. I'm off a smidge, but that's not too bad. Then with a ruler, I can make sure everything's going to line up here. So it's pretty easy to divide circles into 2, 4, 6, 3, lots of things like that. When you get into weird numbers like 11 or 9, it gets more complicated, but not too bad. So now I know my coils will need to live about there on the stator, and they fit pretty perfectly. So now I'll get the stator, which I've already cut out of plexiglass. I'm going to put a piece of steel down. Okay, so that's kind of a template I'm going to use. And then I'll put this on here and center it as best I can. I could center it better if I made a little hole in the very center here, but um, actually maybe I'll do that. Sometimes it's worth it to take the time and do it right. It's easy to line up concentric circles even if they're not exactly the right size. That's pretty close to the stator, so now I can visualize center even better. So yeah, this I just cut out of, I used a bandsaw. Could have used a coping saw or something, but cut this out of acrylic sheet. I think that's pretty well centered. Now I'm going to clamp that down so it doesn't move when I glue the coils down. And since I got magnets kicking around, I'll just clamp it down with magnets. I could tape it, but we'll just do like this. Magnets are handy for lots of things. So now I have a really good guide to glue the coils down. There are the coils. And I'll glue these down with Sign acrylic glue again. And I'm going to glue them down so that the back, or the top, whatever we call it, the top side of the coil is facing down to help pin this wire down. It'll make it more robust, and the top of the coil will be exposed to the top magnet rotor. I could cover it with another sheet of acrylic, but I really want to keep the gap between the two magnet rotors as skinny as possible. It really makes a difference in output. So I'm not going to cover the top of the coils. So I'm just going to put some glue around here. Like so. And I've got some activator, and that'll set the glue up pretty quick. So I'm just going to put this coil in its space exactly where it goes. In between the lines, and just so I can see the edge of the edge of the 4-inch circle, so I know the magnet is centered over the hole. I'll hold it there for a few seconds. And I'll just do that to all the coils. So there's 3 down, and as I go I keep looking at the lines, making sure I'm not getting over the lines. But it's coming up pretty good so far. So that's all. All the coils are glued in. Next step is hooking them up. And I can talk more about single and 3-phase later, but in this case, any 2 coils directly across from each other, because there's 8 magnets. Here, if we have a north, south, north, south, north, these 2 are north. So any magnets, any 2 coils directly across will be in phase with each other. So these 2 coils all have a choice I can hook them either in series or parallel because they're in phase. In this case, I'll want higher voltage, so I'll be hooking those in series, this one and this one, meaning inside of the coil to the outside of this coil. Same thing here, inside of this coil to the outside of this coil, inside of this coil to the outside of this coil. And then I'll have the choice to either wire it in delta or star, also known as WYE or Y. And I'll be hooking it up in star or Y, again to get the voltage up higher in this machine. Anyhow, I'll pull the stator off real quick and I can show. Hopefully it's fairly rigid and kind of neat looking. This should be pretty good, and it's pretty rigid. It should be fine for the purpose. I'll put more glue around here probably and strengthen it up a little bit, but this should work just fine. That's all till next time. Next video I'll probably be putting together the bearings and things.